Good morning to all. Today I am going to take a topic on Maxwell's Boltzmann distribution of velocities. We know that the kinetic gas equation PV is equal to 1 by 3 nmu square. It is derived from the assumption that all the molecules in the gas are having the same velocity, but it is not so. We know that the gas molecules are in a random motion, and during their motion they collide with each other. And during that collision, they may transfer the energy between them. The molecule which gains the energy, its velocity gets increased, and which loses the energy, its velocity gets lowered. So, the gas system consists of a large number of molecules, and millions of collisions takes place in 1 second. From that, we can understand that the velocity of the molecules is not constant for all. It it undergoes changing from 0 to infinity. So, the James Clerk Maxwell studied about this distribution of velocities, and he derived an equation which is based on the probability of loss, which says that the fraction of molecules possessing a particular velocity is only very few. And he derived an equation which is called the Maxwell-Boltzmann distribution of velocity. And that equation is dnc by n is equal to 4 pi into m by 2 pi rt, the whole raised to 3 by 2 into e raised to minus mc square by 2 rt into c square dc. This is a famous equation and is used to find out the most probable, the average, and the root mean square velocities. Here, the terms I can define. dnc is the number of molecules possessing between the velocities c and c plus dz. And n is the total number of velocities, m is the molecular mass of the gas, and T is the temperature in absolute scale. Then, using these distribution velocities, he studied about a number of gas systems and their distribution, and he plotted a graph against a fraction of molecules possessing different velocities. The graph can be: Maxwell plotted the fraction of molecules against the molecular velocities, and the graph he got is like this. And from this graph, we can understand that the molecules which possess the lowest velocities is very few, and the molecules which possess the highest velocities also very few. The intermediate molecules possess the velocities which is very close to the average velocities, which is shown by the curve. The peak of the curve shows the most probable velocity, that is the velocity possessed by the maximum number of molecules. And the first curve is shown at a particular temperature, T1 Kelvin. When he studies the same molecules at different temperatures, he get another curve that is represented by the second curve. The second curve shows that when the temperature increases, the curve shifted towards the right. That is, at the higher temperatures, the velocity possessed by the number of molecules also increasing. And using this curve, we can find out the equation for most probable velocities. Most probable velocity. It is the velocity possessed by the maximum number of molecules. We can derive an equation for this velocity from the Maxwell's equation. And we know that the Maxwell's equation is dnc by n is equal to 4 pi into m by 2 pi rt, the whole raised to 3 by 2 into e raised to minus mc square by 2 rt into dc into c square. Okay, then this equation is differentiating this equation with respect to c and equating it to 0. Differentiating means d by dc of dnc by n is equal to 4 pi into m by 2 pi RT raised to 3 by 2. Here we can do one thing. This m by 2 pi RT is a constant, so we can take it as a constant outside. So m by 2 pi RT raised to 3 by 2 into 4 pi c square into e raised to minus mc square by 2 RT into dc. Here we are going to differentiate only this term because this is a constant. Here we are differentiating this term using the product rule, and we can write that m divided by 2 pi RT whole raised to 3 by 2 into, using product rule, we can differentiate this as 4 pi c square into e raised to minus mc square by 2 RT into minus 2 mc by 2 RT plus e raised to minus mc square by 2 RT into 8 pi c. Here also, these two terms are common, so we can take it outside. So m divided by 2 pi RT raised to 3 by 2 into e raised to minus mc square by 2 RT into 4 pi c square. Here 2 and 2 get cancelled, so we get only minus mc by RT plus 8 pi c. Okay, then the condition which satisfies the maximal point is, that is, we are already I have said that we are equating this equation to 0, and the condition which satisfies the extremity is the integral differential of d by dc of dnc by n cannot be 0, because fraction of molecules always be a positive value, it cannot be 0, and the term m by 2 pi RT raised to 3 by 2 into e raised to minus mc square by 2 RT cannot be 0. The only term that can be 0 is 4 pi c square into mc by RT plus 8 pi c. Rearranging this equation, here there is a minus term also. So minus 4 pi c square into mc by RT is equal to minus 8 pi c. Here c and c get cancelled, pi and pi get cancelled, 4 and 4, 8 get cancelled, and we give 2 value. So we get c square into m by RT is equal to 2. That is, c square is equal to 2 RT by m. Therefore, we can write c is equal to root of 2 RT by m. The most probable velocity is represented by Cm. Therefore, we can write that Cm is equal to root of 2 RT by m. This is the final equation for most probable velocity. Hope that you will understand. Similarly, we can derive an expression for the average velocity also. Average velocity means the velocity maximum velocity, that is the velocity possessed by a large number of molecules. We can derive, we know that the average means a system of numbers that is divided by the total number. We are having n molecules in a gas system and their velocities are C1, C2, C3, etc. up to Cn. So the average velocity can be written as C equal to C1 plus C2 plus C3 plus etc. up to Cn divided by the total number n. The fraction of molecules which possess a C1 velocity is a few and C2 is also very few. So we can find the average velocity by summing up of the products of the velocity and the fraction of molecules possessing that velocity. That can be written as average velocity is usually represented by the letter C bar, which is equal to integral of 0 to infinity C into dNc by n. dNc by n is the fraction of molecules possessing the velocity c. For dNc by n, we can substitute it from the Maxwell's equation. That is integral of 0 to infinity c into dNc by n can be substituted from Maxwell's equation, that is 4 pi into m by 2 pi RT raised to 3 by 2 into e raised to minus mc square by 2 RT into c square dc. Rearranging, c bar is equal to integral of 0 to infinity 4 pi into m by 2 pi RT raised to 3 by 2 into e raised to minus mc square by 2 RT into c cube dc. This c and c square will combine together to form c cube. Okay. 4 pi into m by 2 pi RT and e raised 2 pi RT raised to 3 by 2 is a constant, so we can take it out. That is 4 pi into m by 2 pi RT the whole raised to 3 by 2 integral of 0 to infinity e raised to minus mc square by 2 RT into c cube dc. Here we can substitute for m by 2 RT, m by 2 RT, which is equal to small b. Now the equation becomes 4 pi into m by 2 pi RT raised to 3 by 2 into integral of 0 to infinity c cube into e raised to minus b c square into dc. It is like the expression from the integration, that is 0 to infinity x cube e raised to minus b x square into dx, and its solution is 1 by 2 b square. So substituting this in the above equation, we can write 4 pi into mi 2 pi RT raised to 3 by 2 into 1 by 2b square. For substituting for b, we can write 4 pi into m by 2 pi RT raised to 3 by 2 into 1 by 2 into 2 RT by m the whole square. Now 2 and 4 get cancelled to get 2, and then we can write 2 into pi into m by 2 pi RT the whole raised to 3 by 2, and here it is 2 RT by m. We can write it in the inversion, that is m by 2RT. Now it becomes 1 by 2, and adding this we get pi can be taken outside, 2 pi by pi raised to 3 by 2, and adding m by 2RT raised to 3 by 2 and m by 2RT raised to 1 by 2, we get m divided by 2RT raised to 2. Now, pi divided by pi raised to 3 by 2 becomes 2 by pi raised to 1 by 2, and 2 we can write m by 2RT square can be written as 2RT by m the whole raised to 1 by 2. Now the 2 is out of the root, that is it can be taken inside, and we can write 4 divided by pi into 2RT by m, and finally we can write C bar is equal to 4 into 2 8 RT by pi m. Here root also, so C bar is equal to root of 8 RT by pi m. This is a final equation for average velocity.